concrete buildings, and today on steel buildings. My name is Madan Elimalai. I'm based out of the Singapore office of Bentley. So before I start my presentation for today, I would like to know the softwares that you use currently for designing a steel building. So please help me answer this poll. I'll just give you 10 seconds for answering this poll. You can answer more than one. So it's a multi-choice, multi-answer poll. Please help me answer this poll. And I'll show you the results in 5 seconds. Okay, thank you for joining in this poll. Let's see the results. As I expected, 85% of you use StatPro, 4.5% use RAM structural system, 22% of you use ETAPS. Okay, this is as expected, but just to confirm the usage. The message I want to convey here is many users still use StatPro for building design, which is okay, but my message here is StatPro is a general purpose structural analysis and design software. It is not a specialized software for buildings. So my suggestion is to use the RAM structural system for buildings, both steel buildings as well as concrete buildings. Since RAM structural system is not a general purpose software like StatPro, but is a specialized software for building, it is much more easier to finish the building project using RAM structural system when compared to StatPro. I'm a user of StatPro for the past 25 years. I used to use StatPro for buildings, but after I learned RAM structural system 15 years back, after I joined Bentley, I never used StatPro for buildings. I use StatPro for other type of structures, but for buildings, I use the specialized software for buildings, that is RAM structural system. Okay, that's the message I want to convey for this poll. Let's move on to the next poll. Please specify your role. Are you an end user, structural engineer, or you're a decision maker? So this will help our sales team and marketing team. So I'll just give you 10 more seconds to answer this poll. And then we can move on to our topic for today. 5 more seconds. Okay, thank you for attending this poll. So the synopsis for today's presentation is similar to the yesterday's synopsis, but slightly different because this is steel building. So traditionally, many architectural engineering construction companies use different vendor software products for modeling, like Revit, they use modeling analysis, they may use StatPro, member design, they may use StatPro, connection design, they may use a spreadsheet or manual calculation or a software like RAM connection. And detailing, they may use another software like Tekla Structures or Pro Structures. And for quantity estimation, they use another software. Okay, so the trouble lies in the interoperability of these different vendor products that kills the benefit of BIM. So many companies nowadays, you can see they are adopting BIM, but whether they are successful in BIM is a question. And how do they measure the success of implementing the BIM is another question. Okay? So BIM is a process, as many of you know. It's not a software, it is a process. In order to make this process successful, smooth interoperability between the above software is important. Bentley Structural Enterprise Worksheet provides the solution in allowing the user to interoperate between these multiple softwares seamlessly. So what is this Structural Enterprise Worksheet? The previous name for this bundle is called Structural Enterprise License, and this year we are changing the name as Bentley Structural Enterprise Worksheet, and next year it will be Structural Worksheet. So the transition name is Structural Enterprise Worksheet. Okay, so this is a bundle license of around 8 products from STAD and RAM brands. It includes StatPro Advanced license. It includes Stat Foundation Advanced. It includes RCDC FE, not RCDC. RCDC is part of StatPro Advanced and StatPro. RCD-CFE is a new program for slab and mat foundation design and detailing. And then we have RAM structural system, RAM concept, RAM connection, RAM elements, and microstrand advanced. So these are the 8 programs that are included and bundled in one license called Structural and Enterprise Worksheet license. Okay, and in today's presentation, I'll be focusing on number 4 and number 6, that is RAM structural system and RAM connection for steel building analysis and design. Many of you are already familiar with StatPro. Okay. So the big picture of this structural enterprise worksheet is on the screen. You can see on the left side is all these 8 softwares bundled together, and in the middle you can see this ISM, which stands for Integrated Structural Modeling. It's a neutral file format used to exchange the information from one software to other. And on the bottom, you can see our competitors stand out to be our partners in co-developing this ISM plugin. So Tekla Structures can import a StatPro model, can import a RAM structural system model through this ISM plugin. Same as Revit. You can see the double arrow. And not just import, you can also export from Revit to RAM or Revit to Stat. Okay. And on the right side, you can see Bentley's BIM program, Open Building Designer, and Detailing Program Pro Structures. So Open Building Designer is equal to Autodesk Revit. Pro Structures is equivalent to Tekla Structures. Okay. So the next slide shows the Bentley's connected data environment, where you can see Bentley's hundreds of products used across various industries. So let's focus now on the RAM products overview. What structures are designed using RAM? High-rise buildings, medium-rise buildings, could be an office building or residential building or education campus or medical campus, public buildings or retail buildings. So you can see these programs all are specialized. These RAM brands are all specialized on building type of structures only. You cannot use these RAM products, particularly this RAM structural system, for anything other than buildings. Okay. And so what type of structural systems can be designed to use with RAM? Structural steel, reinforced concrete, post-tension concrete, timber, masonry, and foundations. Why use RAM brand? Because this program is not a general purpose program like StatPro. It is a special purpose program. It is custom made only for buildings. So many tasks are much easier to do in these programs. And all the building code requirements are comprehensively implemented, such as a live load reduction code, seismic code, wind load code, and load combination code, etc., etc. Okay. And many extensive tedious, time-consuming tasks are extensively automated in this program. For example, the alternate span loading for live loads and many other repeated time-consuming tasks are automated here. The program also can produce some detailed drawings, general arrangement drawing, can be used not just for steel and concrete, but also for timber. And after you finish the design, you can do the design check options where you can do trial and error of optimizing the members. So basically, RAM should consist of these 4 products: RAM structural system, RAM concept, RAM connection, RAM elements. So on the screen, you can see a 4-story building. The bottom 2 floors are concrete and the top 2 floors are steel, and the various RAM modules used in designing these 2 programs. Using these 4 programs, sorry. So the steel portion of the structure, complete analysis and design, complete modeling analysis can be done in RAM structural system. And then when it comes to design, you can use RAM structural system to design the steel members, RAM connection for the steel connection, RAM concept for the flat slab, one-way slab, two-way slab, post-tension slab, including the column drops, and RCDC for the concrete beams and columns, and RCDC or RAM concept for the foundation design, etc. Okay. Note that one single program, RAM structural system itself, can do the complete building, including concrete and steel. But nowadays, the RCDC program is developing very fast. So the detailing features of RCDC are better than RAM structural system. So that's why I would recommend to use RCDC for concrete, beam, column, wall, shear wall, and foundation design, except for mat foundation where RAM concept is the solution. Okay, RAM Elements is a general purpose program like StatPro, but it's not a huge program like StatPro. It is capable of doing at least 50% of whatever StatPro can do. Many users use it for this timber design, timber roof truss design, and also the masonry structures. Basically, his strength lies in his modules like retaining wall module, single beam module, single column module, etc. So who uses RAM? Structural engineering consultants like WSP, AEC firms, EPC organizations, building contractors, they use RAM worldwide. Let's see a case study for steel building. On the screen, you can see this medical center in the United States. This is the popular Poplar Bluff Regional Medical Center in Missouri. Is in a 7-story, 425,000 square foot, 250-bed hospital designed to add 50 more beds in the future. It's located near the New Madrid Fault. This $173 million project was classified as a high seismic risk and required seismic design according to the stringent requirements. Design and construction had to be accomplished within 20 months. Stanley D. Lindsay and Associates used RAM structural system to provide a safe, economical design solution. Structural design information was transferred directly to the Revit model using the ISM feature, which I explained in my previous slide. The steel detailer then transferred information to the SDS2 model. And the SDS2 is not ISM compliant, so you have to use the other interoperability features like IFC through the ISM. To interoperate between SDS2, which is a detailing software similar to Tekla Structures or Pro Structures. The ability to trade 3D models among disciplines facilitated the shorten and the sharing of the most current design information. As a result, the production schedule was reduced by half, saving man hours and costs. That is exactly what we are trying to achieve by implementing BIM in your organization. Okay, so interoperability among the products is one of the key in the successful implementation of BIM. Okay, so with that one case study, we have several case studies, but I don't want to spend more time on the case studies. Rather, we spend more time on the software features. So we look at this 4-story steel building model, analysis, design, and detailing. So first, let's go through the modeling overview. Yesterday, for the concrete building, I spent more time in the modeling, but today I'm not going to do that because we have more things to cover. So the modeling is same like the concrete building, which I showed yesterday. So here's a short video clip that shows the first screen of RAM structural system. And the model I already created. It's a simple modeling, 4-story building. Same way, how do we model a concrete building like yesterday? The same way, we just change the material from steel, concrete to steel, and then we model it. So this is the criteria page where we specify the live load reduction code. I used IBC code, but you can change it to UBC or any other international code. And the self-weight, I'm going to consider the self-weight calculation for almost all the members except the slabs and decks, which I'm going to specify manually. And the master steel table, I'm using the American metric table. We also have the international table. And the design steel table, I'm going to use the composite deck as American deck library, and column and beam, I'm going to use the RAM AAC metric table. And similarly, we have the cellular beam, castellated beam, joist, as well as buckling restraint bracings. Okay, and other criteria you can see, you can modify. I'm using the SI units for this example, and for concrete, I'm going to use the metric bars, RAM metric bars. And now I'm going to the modeling mode, and this is the plan layout, the floor layout, typical floor layout of my steel structure. I'm viewing the 3D view now. So there you can see a simple 4-story steel structure. You can see including the foundations. The foundations are all pile caps, and the three floors. Out of the floors, the three bottom floors are made of composite floors, and the roof is made of non-composite sheeting. Okay, and you can see the columns and beams. Most of them are blue color members, meaning they are gravity members, and some of them are red color members. They are the lateral frames that takes the lateral load, such as wind load and seismic load, along with the gravity load. Whereas the blue color members, which I just switched off, will participate only in gravity load analysis. It is this lateral members which is very important in carrying both the lateral as well as gravity loads. So this is the ability of this program to model gravity and lateral members so that the engineer has more control on distributing the lateral loads. And this is the grid layout which we used in this model. The grid spacings are approximately 9.75 meter in the X direction. So it's a combination of orthogonal as well as radial grids. It's very easy to create it in RAM structural system. Also, otherwise, if you have this grid already created in an architectural drawing in a CAD program, we can import that easily. Yesterday, I shown how to import the grids. And the Y direction grids are approximately 7.5 meter. Okay, and now we are seeing the deck slab property information. So we are using this Verco W3 Formlock composite deck. Since in the criteria page I have selected the American decks as the library, so here you can see all the composite deck library from the American manufacturers. Similarly, if you change the criteria from US manufacturers to UK manufacturers or Australian manufacturers or European manufacturers, this library will show up the manufacturers in that particular location. And here we see the story information. So the floor to floor height is 4.5 meter height. Once again, the 3D view of the 4-story structures. Here we do not have a lift core. Since it's just a 4-story building, we just have staircase at 3 locations, which are shown as openings in the roof. You can see on the middle and left and right. Let's view the elevation view of this frame. So here you can see the elevation view. And here you can view the beam labels and column labels. So you can see I'm using the W610 by 101 for the beams for the composite floors and W360 by 91 for the columns. And for the roof, I slightly changed the member size. Okay, so the modeling, I don't want to spend more time on the modeling because we have to cover many features in this limited time. Okay, it's very simple modeling, same like the concrete modeling yesterday. Now we'll move to the gravity loads. How do we apply the gravity loads? Again, with the help of a 2 minutes clip video, I'm going to show you how do we apply the gravity load using the RAM modeler. So all we need to do is just go to the property table and use the load menu, and you can see the 4 options here. The first option is the surface load properties. So there you specify the dead load and live load and the construction dead load and partition loads and mass dead load, everything in one dialog. So I use a dead load of 3 kilonewton per meter square. Remember, for when the criteria page for calculating the self-weight, I have not opted for calculating the self-weight of the slab automatically. So that's why here I'm specifying the dead load of the slab manually. And for the roof, I have 2.4 kilonewton per meter square, a live load of 1 kilonewton per meter square for the roof. Okay, the mass dead load at the bottom will help you when you do the response spectra analysis. And now that we have created the gravity loads, now we are going to apply to the floors. So it's so simple. You just pick and select and apply to the floors as a physical object. Just like the modeling in RAM is all physical modeling, even the loads are all physical. So the load belongs to this slab as a surface load. Similarly, you can apply line load and point loads, if any. For my case, I have not added any line load, just the surface load for both the floor layout, typical floor layout, and the roof layout. So now you can see RAM modeler is showing in green color, meaning that we have finished the modeling using RAM modeler. Okay, now we'll proceed with the gravity beam design, including floor vibration check. Okay. So the gravity beam design is done using the RAM steel module of RAM structural system. So again, with the help of this 5 minutes clip, I'll explain this RAM steel beam, sorry. So on the left side, you click the menu, and you can see now we are in RAM steel beam. Here we need to choose the steel design code. So I'm going to use the AAC 360 2016 LRFD code. And we can specify the demand by capacity limit. By default, it is 1. I'm reducing it to 0.9 for the steel beams, for both deflection as well as strength criteria. And we have a few more criteria that needs to be specified, such as the beam design defaults. I leave it to the default. And deflection criteria, again, I'll leave it to the default. The program will check for the deflection also for both the composite as well as non-composite beams. I'll leave it to the default. And camber. So here we can specify the camber criteria for the composite beams. I'll leave it to the default again. So minimum camber I'm using 19 millimeter, okay, as per default. And here's the strut criteria for the composite beam. The minimum percentage for full composite is 25%. The maximum is 100%. And when the program gives warning that the beam fails in minimum composite requirements, the program will use the bare steel strength and not the composite strength. Okay, so now that we specified all the criteria for the gravity beams means only the blue color members. And now we are performing the design. And the program will select a suitable size for all the gravity beams automatically. So it gives 14 warnings. And these warnings mention that some beams cannot fit enough struts for the minimum 25% composite action. So the program will then consider 0% composite action and will design for the bare steel strengths and not as a composite beam. It will design as a simple steel beam. Okay, now we can see the results, that is the member selection. Let's view a little closer for zooming into some location. So what you see is the beam size selected by the program automatically. W410 by 38.8 is the metric American section. And in the bracket, you see 24, 31. They are the number of struts the program calculates automatically. And then the camber. Okay, so the program shows that in one screen, the complete selection. And now we are going for the vibration check. This vibration check, floor vibration check, is developed by a company called Floor Vibe, which Bentley has an agreement with them, and we pay them royalty, and then we give it to the user as part of RAM structural system. So here I'm going to design the this beam for floor vibration. So the program can evaluate, and you can see the result of this evaluation for the selected beam. Does not satisfy the criterion. Okay, so then I can go ahead and change the beam size and the neighboring beam size as well, and then evaluate it again. And you can see now still it does not satisfy. But then clicking on the advice menu, the program will give you the advice what you need to do, increase the stiffness of the beam. Okay, so again I go back and change the beam size slightly and redo the evaluation. And now you see this, the system satisfy the criteria. So by using this Floor Vibe program, we design the flow, we design the beam, composite beam, so that it is satisfying the vibration requirements. This is very important for steel structures. I don't know how many of you stayed in steel buildings. I myself personally have this experience of this vibration problem while staying in a steel building in the US. There's a hotel, and many times we can see this vibration. So this is a very important check that I feel that needs to be done for steel buildings, vibration check. So for more information about this program, you can view this floorvibe.com. But note that this is provided along with RAM structural system. So you don't need to buy any extra license. So very important, particularly if you plan to use that floor for rhythmic activities like gyms or such activities where you perform rhythmic activities. Now let's view the beam summary. So here you can see the report for the beam gravity steel beam design summary. And now we are looking at the roof beams where there is no studs. And now we are looking at the other floors where we have the studs. Note that all these beams are designed only for gravity loads. We can also produce a report for individual beams. Here you can see the composite properties in detail and the stud calculation and the controlling gravity load combination. We can also view the loads applied on the beam and also the diagrams, like the bending moment and shear force diagram for the gravity load combinations, which you can select at the bottom. And since this is a gravity beam, it doesn't need to be analyzed using a finite element analysis. So you just use the RAM steel module to design this W L square by 8 simply supported beam, because it's a gravity beam having release at the ends. Okay, so now that we have finished the design of the gravity beams, including the floor vibration check, let's move on to the next, that is gravity column design. Okay, again, with the help of a 3 minutes video, I'm going to show you how we perform this gravity column design using RAM steel in RAM structural system. So now that we have finished the steel beam, you can see RAM steel beam is showing in green color. Now we click on the RAM steel column. Now we are in the column module, which shows only the columns, including the lateral and gravity columns. Here we select the design code and base plate design code. I'm using the American codes for this example. And here we specify the demand capacity limit. By default is 1. I'm reducing it to 0.9 to have some 10% cushion there. And here I'm specifying the trial groups, assign some default members to start with. And when I perform the design, the program will use the same profile which you used. For example, if you used a I section, the program will optimize the I section. If you use a hollow section, the program will try to optimize within the hollow section table. And similarly for the base plate, here I'm going to give whether it's a square base plate and the base plate properties. And running the design, the program will now optimize all the gravity steel columns and also the base plate. It will also design the lateral columns, the red color columns, also for gravity loads with the asterisk mark. That's why you see some members, it shows the asterisk mark. Blue color indicates all the members are passing. Any other color indicates they're passing, except that you see any red color. Red color members means fail, having a ratio of more than 1. So those are the members we just saw, lateral members, which are having asterisk sign. These are gravity members. Now we see a combination of both. Okay, so the lateral members again needs to be code checked for lateral loads later, which I'll show you a little later. So now we pull out the design summary for our gravity column design. So we use the building code as IBC and the steel design code as AAC 360 2016 LRFD code. So this summary page shows you the column line and the levels and the axial and the moments, the biaxial moments, and the governing load case and the interaction ratio. We can pull out the material takeoff. This will give you the quantity takeoff of all the gravity steel columns, the lengths and the weights. And that's it. We have now finished the gravity column. And just in case if any of the column failed, you can go to this view update menu and you can modify the steel section and you can analyze it and produce a report and watch for the signal. It should show the green signal. For all the gravity columns, the program will optimize the section automatically, except the lateral columns where the program will use the member size provided by the user. So here we have the option to change the size and reanalyze it and watch for the signal to check the result. It's a very handy feature for designing our columns, gravity columns. And now base plate design. This is the report for our base plate. For each columns at the base, you can see the size of the base plate as well as the thickness and the grade of the steel. So this is applicable for all the gravity columns. For the lateral column, we need to design it in more detail using ram connection. Because gravity columns are pin-ended connections, so that's why it's easy to use, design it using ram steel itself. Whereas for lateral columns, they are fixed end columns, so we need to design them using ram connection. Okay, so now that we have finished designing the gravity columns, let's move on to the lateral loads and analysis. Note that till now, we have been designing all our gravity columns and gravity beams only for the gravity loads. We haven't even applied the lateral loads such as wind load and seismic load. And that's what we are going to do it now. That will be useful for designing our lateral members later. Okay. So to do this lateral frame analysis, lateral loads application and lateral analysis, we have to move to ram frame. Okay. So again, with the help of a short video, I'm going to show you how to do this in ram frame. So now on the left side, you can see the ram modeler, ram steel beam, and ram steel columns are all shown in green color. Now we are in ram frame module. So in ram frame module, we first specify the criteria of specifying the type of analysis. By default, a P delta analysis is selected, which I'm going to accept it. And then the solver, I'm going to use the direct spot solver, in-core spot solver, and I'm going to use all the available CPU cores in my computer. Okay, so those basic criteria and the diaphragm, I'm going to use rigid diaphragm for this model because the floors are all composite floors. For the roof, I may choose to either use rigid or non-rigid, semi-rigid diaphragm. So all the options are available in this program. For this example, I'm still using as rigid diaphragm for the roof. And again, the ground level, I'm going to use as the base level. In case if your structure has basement floors, then you can choose the base floor as per your requirement. Okay, and here's the wind load. Here you can see all the international wind load codes. I'm using the ASC 705 IBC 2000, IBC 0609. Okay, so here you can specify the exposure factor as an exposure category and the basic wind speed at the bottom. We'll leave the program to calculate the rest of the things such as the natural frequency and the gust factor, etc. So we have generated nearly 12 wind load cases. The program generates that automatically. And now is the seismic load. I'm using the ASC 707, IBC 2006-2009. And we can generate this equivalent lateral force, seismic equivalent lateral force for the provisions of member forces or for the provisions of deflection, otherwise serviceability. Okay. So this time I'm generating it for the member forces. I'm going to specify the direction as X and Y and eccentricity plus and minus. So that generates all these seismic load factors. And I'm also generating the dynamic eigensolution. We can also analyze our structure for response spectra. But our structure is a simple 4-story structure, so the response spectra is not needed here. So I'm generating only the eigensolution. Next is the notional loads. The program has inbuilt the ASC 360 code for generating the notional loads, as well as many other international codes for generating the notional loads. So I just specify, click a button, and the notional load cases are automatically generated. That's it. And now all we need to do is run the analysis. And since it's a simple 4-story structure, it just took 3 seconds to complete the analysis. Since we use a rigid diaphragm, there's no need to mesh the flows. And the load combinations we can generate as per all the any other international codes. So in this case, I'm going to use the ASC LRFD code, ASC 7 2016. Okay, so the load combinations are all done. Now we can look at the reflection diagram. As soon as we move to the reflection diagram post-processing results, you can see only the lateral members in my structure are visible here. And you can animate the reflection diagram as per any load combinations. You can rotate while animating. So this is the most important portion of my 4-story building, the lateral frames, 4 on all the directions and there were 2 frames in the middle. Okay, so I hope that gives a clear understanding of the arrangement of lateral frames in my 4-story building. We can view our bending moment diagram, shear force diagram for only beams or only columns or both. So all the options on this dialog box. Axial force diagram, shear force diagram. Okay, all the post-processing, you can do it in the RAM frame itself. Now we are going to view the story shear, frame story shear, and we can view it in the horizontal direction, lateral directions. This time I'm going to view it in the X direction. So there you can see the story shear. And now in the Y direction. In RAM structural system, X and Y are in the plan, the horizontal direction, unlike StatPro. The vertical axis is Z axis, unlike StatPro. Okay, so graphically, we can view this lateral story shear. We can also view the mode shapes. Since I extracted the eigensolution, so to find out the weakest direction of my building, the first mode shape will help me. So that is the weakest direction. This is second mode shape, second weakest direction. And this is the third mode shape, which is twisting along the global Z-axis for RAM structure system. We can also plot the center of rigidity. The program will give the coordinates of the center of rigidity for all the 4 floors. And if you do a response spectra analysis, we can also plot the center of mass. But in this case, I didn't perform a response spectra, so we are not able to view the center of mass. Okay, so various reports you can pull out, such as the member force report, support reaction report, building story shear, frame story shear, story displacement, nodal displacements, etc. So now we are looking at the report of building story shears. So here you can see for each load combinations, we can see for each flow, the story shear distribution in both the axes. And next is the support reaction for our lateral members. So these support reactions are useful to design the base plate and foundation for the lateral frames. Okay, so now that we have finished applying the lateral loads, we finished doing the finite element analysis, and we finished doing the load combinations, let's move on to the next step, that is member and joint code check using standard steel provisions of the code. So when I say member code check, it's same like StatPro. We need to perform the code check of our steel members. Remember, the earlier design is only for gravity steel members, beam and columns. And this member code check is for the lateral members. Okay, not just the member code check, but also even the joint code check the program can perform. So again, with the help of a short video, I'm going to demonstrate this. So we can see green colors on RAM frame. Now we are going to use the steel standard provisions in the RAM frame module. So I'm going to the RAM frame module now, and I'm going to change the menu, the drop-down menu from analysis to steel. Okay, and need to change the code. I'm going to use the latest American code AAC 360 2016 code LRFD, and the load combinations are already generated. And you need to specify the criterias. I can use this criteria menu to specify the design criterias. The K factor, the program will calculate that automatically, but you can specify manually also. Flange bracing. Here we have option to specify whether the beams are braced or not, and the columns are braced or not. Okay. For columns, I'm using the button deck braces column. Other than that, all other options are remain unchecked. Okay, so here you can see the options to assign the K factors for beams and columns. I'm going to use the default. The program will take care of that automatically. And now I'm running the code check. And here we can see the color-coded results of our lateral beams. To view it more clearly, I'm going to switch off all my gravity beams, gravity columns, and the slabs. So now we are able to see only the lateral members. So some of the lateral members are failing. You can view them in red color. So I'm going to show how to make it pass. So using the process view update option, you can see the dialog where you can change the member size immediately for that particular member and hit the analyze button and watch the signal at the bottom. And now you can see it shows green color with the interaction ratio of 0.89. And now I can hit the update database button to update the member size. And I also pull out the results like this. So easy to make the failed member pass. And the user has total control on the member selection. The same way we have to select all other failing members and make it pass. Okay. Another option is you can go back to the RAM modeler and you can specify a bigger member size and redo the analysis. So there are two options available. And here's the final code check summary that shows you the summarized results for all your lateral members for all your load combinations. The size is shown on the right. The member forces are shown on the left. And the interaction ratio is shown and the governing load combination is shown in the middle. Now we move on to the joint code check. And the program will do a simple joint code check as per the standard provisions available in the code. And will show you whether the joint is okay, or web plate is required, or stiffener required, or additional check required, or it's failing. So you can see most of the joints, it shows green color, that means okay, and most of the joints it shows in blue color, meaning web plate and stiffeners are required. And some joints is showing as web plate and stiffener failed. Okay, so that requires a detailed connection design using RAM connection. And here you can see the view update for the joint code check that shows the report and the clauses that is checking as per the code, and the results are showing as okay in green color. Very, very useful report, which we don't get it in StatPro. Joint code check. And now let's look on one of the failed joint. And you see the red color signal. It says the joint is failing because the panel shear capacity with the web plate is not good. So what we need to do is just change the column size. That is the solution. Okay. even though the column is structurally passing, just because of the joint, we need to change the column size. And we can pull out a report, joint check summary, joint code check summary. So this shows all the joints that are passing or require stiffener, either at the flange or web. So the summary report is a very useful report for the joint. Okay, so now we have finished the member and joint code check using the standard provisions of the code. The next thing is to use the seismic provision. Okay, again for both member and joint code check using the seismic provision. Okay, so again with the help of a short video, I'm going to show you how to achieve this. Again, we are in RAM frame, changing the drop-down menu from standard provisions to steel provisions. Here we are choosing the AAC 341 2010. AAC 341 2016 LRFD. We can also choose the old code, even the UBC 97 code also, which is followed in some parts of Southeast Asia. And now we perform the member code check again, and we see the seismic provision check. Okay, so many of the members are showing as the red color, meaning they are failing. And we can go to the view update, and we can see the reason for failure, stability bracing of beams. Okay, that's the reason for failure. So we can choose the view results option to view a detailed step-by-step calculations to understand why this beam is failing. Okay, stability bracing beams, highly ductile. Okay, so the solution for to make this beam passing is to change the beam size here itself interactively. So as soon as we change, you see the signal changing to yellow color, and then we hit the analyze button to see whether it's showing red color or green color. Now we make the member pass as per the seismic provision check, as per AAC 341 2016. Again, this is a highly user-friendly manner. It's implemented in RAM structural system. So this way, we can perform the same way for the joint check, seismic check also, joint code check. So again, we can see many joints are failing because of the seismic provisions. Again, we can do a view update to see why it is failing, and then change the column size to make it pass. And keep a note of the sizes that you change, so that you go back to your RAM frame and make sure you're specifying the column size, the changed column size for all the similar columns, so that the structure is symmetrically assigned. The sizes are assigned symmetrically for the structure. Okay, or you can do the view update for one by one for all these joints, but that takes a little bit more time. So you just do it for one critical joint and then note down the column size that is required and go back to the RAM modeler and change the column size. That will be a faster workflow. Okay, so hope that explains how do we perform the member and joint code check for using the seismic provisions as per AISC 341 code. Okay, so the next thing is pile foundation design. This is the only concrete part. So even though the complete steel structure is steel, but the foundation is concrete. Okay, so for this example, we are going to use RAM structural system itself to design all the pile foundation. You have the choice of either using RCDC or RAM foundation inside RAM structural system, but since this is a simple steel structure and here we have only the pile foundation design, I'm going to use the RAM foundation module in RAM structural system to design this pile foundation. Okay, and we do not have any concrete other than this foundation, so we don't need to perform the concrete gravity analysis as we did yesterday. And note that this RAM foundation has only the American code, British code. It does not have the Australian code and does not have the Euro code. So if you are using Euro code or Australian code or any other international code other than British and US, you have to use RCDC. Since for this project, I'm using the American code, which is already available in RAM structural system, RAM Foundation. So I'm using RAM Foundation to design all these pile caps. And note that the program is capable of designing not just pile caps, but also isolated spread footings and also combined footings as well. For Mat Foundation, I can use RAM concept like yesterday. So here I'm specifying the design criteria for my pile cap design. Spacing requirements and the increments, and how the bars are selected based on minimum bar criteria, etc. The pile embedment depth, all those information, and also need to specify the the minimum and maximum sizes for my pile cap, and the pile capacity and pile diameter, and the edge spacing checks, all those things I need to specify. And finally, need to specify the soil bearing capacity. You can use this wizard to calculate this bearing capacity, but for this example, I'm just going to give 200 kilonewton per meter square as my safe bearing capacity. And then I'm going to assign the base plate size for all the columns. For this demo purpose, I'm going to use the same 450 by 450 mm for all the columns. And here's the location where we specify the pile diameter and the pile capacity for compression capacity, tension capacity, and shear capacity. So for a 300 mm pile diameter, I'm going to use the compression capacity of 300 kilonewton, tension capacity as 100, and shear capacity also as 100. And on the right side, I'm going to assign for some columns which are less loaded as 3 piles, some columns which are more loaded, I'm going to use 6 piles, and some columns which are heavily loaded in the center, I'm going to use 9 piles. So after I assign the geometry, I need to specify the load, generate the load combinations for concrete as well as for soil. For concrete, I use the factored combinations as per the ACI 2014. And that then all the foundations are showing in golden color, meaning they're ready for design. And same way, I'm going to assign the soil load combination, the unfactored load combinations. And then I perform the foundation design. You can see all the foundations are showing in green color, meaning they're all passing. Okay, if any foundation is showing in red color, that means it fails. Then you can use the view update button to view the reason for the failure. We can view the step-by-step calculations, and we can very easily find the solution from this report, and then we can redesign by either assigning more piles or by increasing the pile diameter with more pile capacity. So that way we can easily redesign and make the column, make the pile cap pass. So here itself, I can very easily change the pile configuration from 9 pile configuration to 6 pile configuration, and I can redesign. Now we have finished all the pile design very quickly. Now we can pull out some reports, such as the pile footing design summary. So this is just a 5-page report showing the pile cap orientation and the number of piles and the dimensions of the pile cap and the reinforcement for all the piles in our project. Next, we'll pull out some more report, such as the material takeoff. So this material takeoff is just 2-page output, shows the different pile caps in our model and the quantities and the volume and the weight, and the reinforcement quantity, length, and weight, and the total footing takeoff at the bottom on the next page. So that's it. Very quickly, we finished designing the pile caps using RAM Foundation module in RAM structural system. Next is the steel connection design. So this we cannot ignore for a steel structure. So the benefit of using RAM structural system to design the steel connection is that it has the RAM connection module integrated with it. Even though RAM connection is separately licensed, we can call that program inside RAM structural system using the menu on the left side. Okay. So now we are ready for the connection design, as we have sized the gravity members as well as lateral members for both standard provisions as well as seismic provisions. And we have also designed the foundations as well. And now we are ready for the connection design using RAM connection. So we can call RAM connection directly from RAM structural system. And now we are in the RAM connection mode with the complete steel structure module imported here along with the forces for all the hundreds of load combinations. So all we need to do here is select the members that we need to design the connections for. So I'm more interested in the lateral members. So here I'm showing the lateral members in red color, and I'm going in a rendered view, and then I'm going to unselect the lateral members in this rendered view. Okay. And then use invert selection to select only the lateral member. And now we can view it in 3D, and we can view the rendered view. And now we can see all the lateral beams and columns in the view. And now it's very easy for us to assign a connection. So I'm going to use the AAC 2016 LRFD code, design code. You can see the presence of all other international codes. We have the Australian code, New Zealand code, and Indian code as well as the Euro code as well. Okay. We can also design these connections for seismic provisions as well. Okay. And on the bottom, you can select the load combinations for which you want to design the connections. There are hundreds of combinations. And now we can just assign a connection. In our case, we can see here we have basic connections, smart connections, gusset connections, base plate connections, tubular connections, etc. Okay, so for our example, we are going to use basic connections. Basic connections means we are going to use a library of connections which is already available in the RAM connection program. Smart connections means the program will try to optimize everything and doesn't use any library. So for this example, we are just going to assign an end plate connection. Because these are lateral members, the joints are all moment connections. So by assigning an end plate connection, we are taking care of both the shear as well as moment, as well as axial force, if any. Now you see that all these connections are beam flange connections are assigned with the end plate, and the connections are shown in 3D for the whole building. And we can view the skeleton view and double click the gusset plate icon. And there you can see the connection in 3D in RAM connection interface. And notice that this particular connection fails in the ratio of 1.3635. And here you can see the load combinations. All the loads are imported from RAM structural system. And here you can see the geometric considerations. And all are okay except one. And the base beam flange does not fit the size of the beam. So the end plate is size we need to change. So that's the warning. And the design check here, you can see the connection is failing. So this calculation report will help you find the reason why this connection is failing. So after going through in detail, we can very easily modify the connection using the connection pad on the left. So I'm going to change from 8 bolts configuration to 4 bolts for each flange. And next is the weld size. I'm going to change from 4 mm to 6 mm. And carefully watch the signal on the top right. And now its ratio changed from 1.35 to 1.04. Meaning we are in the right direction. Okay. And now I'm going to change the gauge, the bolt gauge, to increase the plate size, the end plate size. Previously, the report was giving some warning. So I'm solving that by increasing the transverse center to center bolt gauge spacing. Okay. So all this you can configure, I can modify the configuration of the connection by using the left side connection pad. And now we go back to the report and see the geometry considerations are all tick marked now. Previously we had the end plate was having a problem. We get some warning. And now all are passing. Now the only problem is the moment end plate, internal flange, no prying bolt moment strength. The ratio is now 1.04. And you need to refer to the design guide for equation 3.7 and equation 3.8 and equation 3.7. Okay, and we need to do is just hit the view formulas button on the top left. That will show the formula that governs this ratio 1.04. So I see this formula. The formula is something related with the distance of the bolt from the flange. Okay. So now that I know what is really governing this equation, I can now go to the connection pad and modify the distance of the bolt, the edge distance of the bolt, the distance from the outer bolt central line to the beam flange. So by doing that change, we are easily making this connection pass. And I'll go back to the report, and we see the 1.04 has now changed to, yeah, that clause is no more governing now. Okay, so we don't see that clause anymore. Okay, so now we can see the report, the detailed drawing. The program produces a detailed drawing, and we can export this to a DXF file in any scale. And we can also pull out the bill of material, showing you the bolt sizes and the plate sizes. So both detailed drawing, bill of materials, as well as step-by-step calculation, including the formula, are all available in a few minutes after we exported the building from RAM structural system to RAM connection. We can also add stiffeners, such as strengthening the flanges by using the stiffener and strengthening the web of the column by using the web doubler, and also diagonal stiffener as well. Okay, but for this connection, we don't need the stiffener because the ratio is less than 1. So we can exit from the connection pad. So same way, we can design all the connections. The main pain point that we are addressing by using this RAM structural system and RAM connection interface is the load cases. The hundreds of load combinations are automatically taken care, and the connections are designed for the worst load combination. Imagine doing this without this interoperability between these two softwares. It is really going to be tough time for the engineer to find out the critical forces that is going to govern this moment connection. And particularly moment connection is going to be difficult because it's not just moment, we have to consider the shear as well as axial force also. Okay, so now you can see the connection, the connection that we have modified just now in 3D. So it is only this lateral members that we need to bother more because they are the one that is going to have the moment connections. All the gravity members is easy to design the connections because they just need to be designed only for shear. Okay, so that's the benefit of the gravity lateral member modeling in RAM structural system. The engineer has total control on your lateral frames, on the distribution of your lateral load. Okay, and next is drawing production. RAM structural system itself has certain drawing production tools. With the help of this short video, again, I'm going to show you how I extract the drawings, the design drawings, general arrangement drawings in RAM frame. In RAM structural system, RAM manager. So here we have the DXF file generation for our floor plans. So you can choose the scale, you can choose the colors and layer names for your steel members, the font size, layer name, everything is fully customizable and configurable. Okay, so we can modify the stud symbols, the text height, everything you can configure. How we are going to represent the steel members, steel beams, steel columns, gravity, lateral, all these are configurable. And just hit this create drawing and specify a file name. The file will be generated as a DXF file so that you can open it in any CAD program. Okay, so same way we are going to generate the floor plans for all of the floors as well. Just use a different file name. And next we are going to generate the column and footing schedule. Since we have finished the pile foundation design in RAM structural system itself, we can generate the drawings for those as well. So I'm going to include the drawing to have the grids also. And we can fully configure the detailing style using the various provisions in this dialog. Okay, and just hit the generate drawing and fill up the file name. That's it. Our drawings are generated. And now we can use this view DXUp option in the program itself to view the drawing. Note that this is a simple viewer, so it's not that great, but you can open it in any CAD program to view it in more detail. Okay, so I'm using this Open Building Designer, which is built on MicroStation, Bentley's flagship program, MicroStation, to show you this drawing in more detail. And I'm going to use the same drawing to import my 3D model from RAM structure system as well. So I'm creating a model in this file, in this DGN file, and I'm going to reference this drawings as a DXF file in this model. And there you can see the drawings generated in more detail. The pile cap schedule showing the reinforcement and thickness of pile cap and the dimensions of pile cap and the pile configuration. And the column schedule showing the sizes for each floor and the footing schedule. So all these drawings are produced at just one button click inside RAM structural system itself. And next we are going to view the floor layout. So before I view the floor layout, I'm just going to name this file as the column footing schedule. Name this model, not the file. It's all contained in one DGN file. Okay, so now I'm going to create another model, a 2D model, and name it as floor plan, level 1 floor plan. And I'm going to reference the DXF file, which I already created in RAM structural system. So the reason why I'm showing all these details is that how we are doing the BIM process by reusing the model from one software to other software. So this is the third software I'm showing you now, Open Building Designer. The second software is RAM Concept, and the first software is, sorry, not RAM Concept, RAM Connection, and the first software is RAM Structural System. Okay, so how we are reusing the same model, the same information, multiple softwares to speed up our project completion. Okay, that's the way we are achieving the success in the BIM implementation. Okay, so we have finished viewing the drawing production. Now we'll go to the last option of BIM interoperability. How we are going to bring this 3D model, which we have just finished the design of the members, connections, foundations using RAM structural system and RAM connection. And finally, how we are going to bring it into our multidiscipline building information modeling softwares like Open Building Designer, or if you use Revit, the same process. So here's the ISM option in the file menu. So here we can specify what exactly are we going to export into the ISM file. Just some basic configuration that we need to do. Most of the time, I'll leave it to the default. And then use the file menu, ISM, create ISM repository. And the file extension is .ism.dgn. So now we are exporting this ISM file from RAM structural system into ISM. This takes a few seconds, and now it asks for the mapping. The composite floor is mapped already, whereas the roof deck is not composite, so I'm not going to map it. So that we take care of locally in Open Building Designer or any other BIM program. So here's some modifications on the default options, and then we are ready now to export the ISM file. Okay, so we have finished exporting the ISM file. Now we are in the Open Building Designer, Bentley's multidiscipline building information modeling program. So here we are going to import the model by using this analysis menu, new from ISM repository. And here we are going to select the ISM file, which we just created from RAM structural system, and just do some preliminary mapping. Most of the time, this mapping happens automatically because these two softwares are from the same company, Bentley. All we need to do is just do some preliminary settings, preliminary configuration in the settings menu, and then hit the import button. That's it. That's it. The entire 3D model, which we have successfully designed in RAM structural system, will be now available in this BIM program. And what is the thing that we are achieving now? Note that when you're actually constructing this building on the site, we are not just going to build the building only with structural components, but also with architectural components like windows, doors, and also with electrical, mechanical, plumbing, etc., isn't it? So before we encounter any problem in the site, we should encounter the problem in this design model using this BIM software, which has the capability to model not just structural, but also architectural, mechanical, electrical, plumbing, etc., and perform clash detections and produce multidiscipline drawings. But note that the important thing that we are achieving in this report is that we are not duplicating the modeling. Notice that if we do not have this import option, we have to model this in the BIM program, which will take many hours, isn't it? Defeating the benefits of BIM, duplicating the work in the same office, which we are avoiding by just importing them, reusing the same model, in bringing into our BIM software. Now we give it to the BIM team to reference their architectural model, their mechanical model, the electrical model, the plumbing model, and perform clash detection, and make sure we encounter the problem in this digital twin model itself before we encounter the problem in the site, which will be very expensive to fix it. Okay, so these are the clash detection tools, but notice that this program, the goal of this webinar is not on the BIM modeling, but more on our structural design. So just this interoperability feature alone, I'll explain here. Okay, now you can see that the composite slabs also are imported successfully. Now we can see the cross section of the composite slab. Okay, and here you can see the composite slab also imported. Imagine modeling this in BIM software without importing. And BIM users can use this model now to produce various drawings, elevation drawings, section drawings, and various reports in spreadsheets, quantity reports, etc. That's it. We have now completed BIM interoperability. And now let me re-emphasize on the structural enterprise license. It's a special bundle license of around 8 products from STAD and RAM brands. It includes STAD Pro Advanced, it includes STAD Foundation Advanced, it includes RAM Structural System, RAM Connection, RAM Concept, etc. Okay, so the big picture on the screen, you can see again, with the help of ISM integrated structural model technology, we can interoperate from our Bentley structural programs to structural BIM programs or detailing programs, either from Bentley or from our partners. And from this ISM, we can even import IFC files from other programs which are not listed in this screen. To summarize, completing a steel building design project requires several software varying from BIM modeling, structural analysis, design, detailing, and quantity estimation programs. Structural enterprise worksheet gives a bundle license which helps complete the project with one license. The ISM technology helps in interoperability between the structural analysis and BIM detailing programs. With the help of the above Bentley structural technologies, we can finish our steel building project more efficiently and at an affordable software cost. So that's the goal or synopsis of this webinar. So please subscribe to our YouTube channel. We have lots of videos there to help you learn more of our Bentley structural programs. So please search for Bentley structural without the space in the middle, and please subscribe for it. Utilize our LAN server. Our Bentley users can access this LAN server for free. All the trainings for all our programs are available on demand for free, including the training materials downloadable as PDF files. Once you complete the training, so you can print the certificate signed by the Global Bentley Institute Vice President. It's all for free for our Bentley users. And support, you can get support from Bentley by using the various resources. The first option is using the communities, the blogs and forums and wikis. And the second option is to use our service request manager. Third option to use Connect Advisor. And the last option, you can email your local contact. Okay, so before I end my presentation and to proceed with the question and answer session, again, we have 3 polls. So please help me answering these polls. The first poll is, now that you have seen RAM structural system and also RAM connection, do you plan to use it for your upcoming steel building projects? So please answer yes or no and hit the submit button. I'll give you 10 more seconds for answering this poll. Please participate in this poll so that we can produce a report about the goal of this webinar, whether the message has been reached out to you, whether you have a clear understanding of the RAM structural system and RAM connection program, because many of our users in this region use Lateral for steel buildings, which is a general purpose program. And in fact, RAM structural system is the hero there. It is a special purpose program for steel and concrete buildings. So we need to create more awareness of this program in this region. Okay, so hope you have answered this poll. Thank you for attending this poll. And let's move on to the next poll. Would you like to participate in our upcoming Bentley Year in Infrastructure 2020 in October 20 and 21 by presenting, not just participating, by presenting your project involving ISM? Okay, we'll give you more details if you are interested. Okay, so we just want to reach out to you if you are interested in presenting at our YII 2020. It is going to be a virtual event this year. Last year it happened in Singapore. This year is going to be a virtual event. Okay, so please help answer this if you're interested in doing a presentation in our YII in October. Using your project involving ISM. Yeah, ISM, as explained in my presentation, is an integrated structural model which will help you to interoperate between BIM softwares, detailing programs, and structural analysis programs. Okay, so if you used ISM in your project, if you're interested to share your knowledge, please say yes, and we'll come back to you with more details. Okay, thank you for joining in this poll. Okay, and the final poll following this webinar, if you want us to reach out to you, our sales team, our technical team, please answer this poll, indicate your preference, and we'll contact you. I'll give you 5 more seconds for answering this poll. Okay, thank you. So with that, I'll open up for question and answer session. On the bottom of your screen, you can see the question and answer box. So please drop your questions there. I'll answer it one by one. For those of you who need to move out of this presentation, you can feel free to drop off. But before that, please answer the surveys at the end of this webinar. That'll be helpful for us to proceed with more webinars in future. Okay. So I already see some 13 questions posted. 13 questions. So I'll read out one by one. Can RAM connection support channels as columns and beams? Yes, the latest version of RAM connection supports the channels as columns and beams. The latest version was released just beginning of this week only. RAM connection latest version supports this channel as columns and beams. Okay. Another question, can RAM connections support tubular to tubular connections? The tubular to tubular connections are supported partly only for the American code. And before the end of this year, we'll be implementing almost all the tubular to tubular connections. Okay. So currently it is supported partly, and that too only for the American code. Okay. So in the upcoming versions, we'll be implementing it for more codes, for almost all the codes, and for almost all the tubular to tubular connections. Most of the things will be completed by end of this year, and by first quarter of next year, everything will be complete. Okay, another question, I don't understand this. Is it an API, application programming interface? Yes, you can do application programming interface with all our programs, including ISM. Yes. Another question, when you are changing member site to make it pause, is the program running global analysis again or checking locally? That's a very good question. Yes, you are correct. The program does not run a global analysis. It is only checking locally. So that's why you can use that feature, that interactive member size changing feature, view update. We call it as view update feature, to check the adequacy of the member, to identify the member that is going to pass, and then go back to the RAM modeler and change it to the beams and all the counterpart beams and do a global analysis one more time. Then only the updated member forces will be correct. Okay. So that is just a helping tool, not the final tool. Hope that answers your question. Okay. Another question, can the program perform any shapes, I shape, H, or hollow, or of joint check? Yes, for any shapes, the program can perform the program can be used for any shape, I shape, H, or hollow for joint check. Yes. Another question, is it a correct approach to pause a beam with manual calculation taking into account of effective depth, effective deck or slab width together with beam properties, even though deck or slab has already been taken into account in the global analysis by modeling as rigid diaphragm? I don't understand your question. You say, is it a correct approach to pause a beam? Or pause a beam with manual calculation taking into account of effective depth, effective deck or slab width together with beam properties, even though deck or slab has already been taken into account in the global analysis by modeling as rigid diaphragm? See, first of all, the global analysis takes into account the global stiffness of all the members and slabs to arrive at the member forces. And then that is analysis. Okay, the analysis takes care of considering the stiffness of all the components that you model. And then when you're coming to code check, which is a design, at that time we are looking at the member properties alone with the composite properties coming in together to check whether that member is passing or failing. Okay, so we are not doing any manual calculation here. So we are using the program to automatically calculate the effective width, the effective flange width of the composite beam, and calculate the composite properties, and then use that composite property calculation in the code check. So I don't think we are doing any approximation here. So it is accurate. We are not doing any manual calculation here. So I don't understand what you mean by with manual calculations. I can interpret your question related. Is it related to, are you talking about the gravity beam member? Because in gravity beam member design, we are not doing a global analysis. So if that is your question, yes, now I can understand your question now. Okay, so note that even for the gravity beam analysis, gravity beam design, we are still considering the flange width, the effective flange width, and we are still considering the full composite properties of the steel beam. So the global analysis result is not really required there, because we are not going to design the member for lateral loads at all. The gravity members are designed only for gravity loads. So for that, the global analysis is not required at all. Okay, so hope I answer your question. Okay. Another question is, RAM already considers soil structure interaction analysis. Soil structure interaction analysis. Okay, when you say RAM, as I explained in my start of my presentation, RAM has 4 modules, 4 programs. One of the modules, RAM concept, which is capable of designing, analyzing and designing your mat foundation. Only that module is capable of doing the soil structure interaction analysis when you provide the soil subgrade modulus. The program will automatically convert that into soil springs and will do a zero tension iterative analysis. Whereas in RAM structural system, it does not do the soil structure interaction, but you can have the option. You have the option to model those supports as springs, but you need to manually do that by calculating the spring manually. It's not automated. Whereas in RAM concept, it is automated. So that's how you differentiate these 2 programs, RAM concept and RAM structural system. And today I have not demonstrated RAM concept because we didn't have any mat foundation in our model. But yesterday, you noticed I used the RAM concept to design the mat foundation. If you have missed that yesterday presentation, you can watch the recording. Okay, next, can it design piles as by ACI 543? I don't think so, but I need to double check and I'll come back to you on this, Romal. As per my knowledge is the ACI 2014, ACI 348, 2014 code. I don't know whether we consider the ACI 543. I'll come back to you on that. Next question is, how is the deflection of piles taken into account for the global deflection of the structure? Very good question. Notice that in this program, RAM structural system, since we don't model the piles as spring, we model them as a rigid footing. So the piles are rigid. They do not have any global deflection. Okay. But for some projects where you need to consider the global deflection of the pile, into consideration, then I would suggest you to specify the support as spring support instead of a rigid support. So RAM frame has the capability to specify the support springs. In my presentations, I haven't considered that. So that's why we are not considering the global deflection. Okay, so but if you model the supports as spring support, then the deflection of your support will be considered in your global analysis. Hope that answers your question. Another question is, can this RAM be used to design open structure with pipes and equipment? See, I would, as I explained in my first part of my presentation, RAM structural system is a specialized program for only a limited domain of structures, a concrete commercial building, a steel building, a campus, like a hospital campus, an educational campus. But you're talking about open structure with pipes and equipment. No, this program is not meant for that. Even though we can tweak, we can struggle to achieve that. My suggestion to you is to use StatPro for that. StatPro is a general purpose program, and that is where is strength for industrial plant structures. It is StatPro. For commercial, residential, campus buildings, it is RAM. Okay. So to answer your question, please use StatPro for pipes and equipment supporting structure. Okay. RAM is not the right software for that. Next question, can RAM connection detect clash between stiffener plates and bolts? See, when you assign the stiffener plates and bolts in RAM connection, it does not do the clash detection graphically, but it does the geometry checking. You remember when I showed the report of the RAM connection in this presentation today, you see the connections were failing due to two reasons. One is for geometry checking, another one is for design checking. So the clash between the stiffener plates and bolts will be taken care of by the geometry checking itself. Then the program will report the signal as yellow color. Yellow color means structurally it may be safe, but detailing have problem. Okay. Otherwise, green color for safe and good, and red color for structural strength failure. Okay. Yellow color for detailing failure. Okay. Hope that answers your question. Another question is, can we design the welding connection in RAM, meaning the thickness of weld can be determined? Yes, the program is suitable for both the weld as well as bolt connections. The program will calculate the weld thickness. Yes, and the latest version of RAM connection has a new feature called weld group and bolt group design, which used to be a feature in LimCon, now implemented in RAM connection as well. Another question, please suggest how to model different column sections. Example, a changed column flange thickness at all beam column joints for small height. Example, for all joints, if column section is different, say in 0.8 meter column height only. In StatPro, additional nodes and section between nodes can be applied. How to do similar workflow in RAM? Okay, I don't know what is the type of structure you are doing. If you are doing some industrial structure or a tapered section, then I would suggest you to use StatPro for that. Okay, because these kind of requirements come in those kind of structures only. RAM use it only for commercial, residential, high-rise and medium-rise building. Okay, for all other purposes, use StatPro. It is possible to do that in RAM, but it's not a straightforward method, because in RAM structural system we need to have a clearly defined floors. Okay, if you want to change the column size for the mid height of the floor, then you need to create a dummy floor at that level. So it's an indirect way of doing that. Whereas in StatPro, it is very easy, because StatPro is a general purpose program. You don't need to define a floor for doing this. You just need to create a joint to split that member and assign a different size for that member. Okay, so please choose the software correctly for your project. Okay. Okay, question on slides. Yeah, please drop in your emails. Those who need the PDF for the presentations, I'll send you by email. Okay, thank you. Okay, another question: can you export stat frame data to RAM? Yes, you can export through ISM. Okay, but note that RAM to stat is easy. Stat to RAM is not that easy, because instead we don't declare the floor layouts. We don't specify the floor levels. Whereas in RAM, we need to clearly specify the floor levels and story information. So that's why RAM to stat is easy. Stat to RAM involves some tricks and tips. Okay, but it's possible. Okay. Another question: is structure modeling similar to stat's physical modeling? The answer is no. Both these programs are entirely different programs. In StatPro physical modeling, you model in 3D. That means you are not limited to work only on the floor plan and elevations. Whereas in RAM structural system, you need to do most of your modeling in floor plans and some part of your modeling in elevation views. But you cannot do modification of your modeling in 3D isometric view. Whereas in StatPro physical modeling, you can do anything the way you want because StatPro is general purpose program. That is its advantage. And that is also its disadvantage because it is not specializing on anything. Okay, so moving on to the next question. Please send a copy of slides. Yes. Okay, so definitely please drop in your email. I can send you the slides. Another question, as the foundation or rigid foundation, what is the difference in assigning the column base as rigid fixed support instead of modeling in the foundation? I don't understand this question. In RAM structural system, by default, the program considers the foundation as fixed support unless we manually go and change the support as pin support. Okay, so those changes we need to do it in RAM frame. Okay, hope that answers your question. So we model the foundation in the RAM modeler. Okay, and in RAM frame, we can modify the support from fixed support to pin support or spring supports. Hope I answer your question. Another question is how to apply rigid beam column connection in RAM structural. Rigid beam column connection that is not pinned, not to have maximum positive bending moment. WS square. Can we apply any joint release moments? Example 50%. Please suggest workflow. So good question. So by default, when you model the member as a lateral members for both beam and column, by default it is a rigid connection. Okay, it's not a pin connection. But when you model the beam and column as a gravity member, then only the member will have pinned connection. So in my yesterday presentation, you may notice that how I showed you how to modify, how to view the releases and how to modify the releases manually. Okay, so I hope I answered that question. But assigning partial moment release, I need to double check that. It's easy to do that in StatPro, but I don't think that feature in RAM frame. But I need to double check and come back to you on that. Partial moment release, I need to double check. Okay, I'll come back to you on that by email. Okay, other questions are all requesting for the slides. Another question, how about the composite slab to beam connection? Did you design it using the suit? Composite slab to beam connection? No. For slab to beam connection, we don't do any connection design. All our connection design are for beam to column, beam to beam, beam to base plate, beam splice, column splice, etc. Not to slab. Okay, we don't have that feature. Another question, can RAM be used for existing building assessment? Yes, in fact, this is one of the best software for the existing building assessment. So when you have some old building where we need to assess it for adding some extra load, etc. For example, you may want to add an extra floor for existing building which was built 20 years back or many years back. So you can use this program to model the existing section sizes. If it is a concrete structure, you can design it, and the reinforcement, you can provide the reinforcement, you can modify the reinforcement as a user-defined reinforcement, and you can provide the reinforcement which is already provided in the existing building, and then add the extra floor or extra load and check whether the existing reinforcement can withstand the extra load. If it is a steel structure, the workflow is even easier. You just need to model the existing steel section beam and apply the extra load or extra floor and see the existing beams are passing or not. If it is not pausing, then you need to strengthen the beam, replace the beam with a heavier beam, or you need to strengthen the beam by other ways, by adding some extra plates or the flanges and webs and so on. So, okay. So yes, definitely this program can be used for assessing the existing building. Another question, can RAM structural system design column splices at floor level where the upper and lower column sections are different sections? In RAM structural system, you just need to indicate the program, the column column splices. It doesn't design the splices. For splices, we need to use the RAM connection. Okay, so RAM connection is the program that designs the connections, the splice connections also. Okay, in RAM structural system, you just need to indicate the location of the splices. that you need to specify in the story dialog. When you specify the floor height, floor to floor height, at the time we usually specify the splices are at every floor or at alternate floors. That's where you specify the splice location. But the actual splice design has to be done in RAM connection after you export the RAM structural system model in RAM connection. Hope that answers your question. Okay, so with that, the questions seems to be over. So hope you guys enjoyed this presentation today. Please don't forget to answer the survey questions following this presentation. Thank you for joining today's presentation on Bentley Structural Technology for Steel and Buildings. So with this, we complete this webinar series on concrete and steel buildings yesterday and today. Hope this session was useful for you to understand the RAM product features. Thank you once again.